Next, I would like to call upon Mr. David Liu Chia Chyi to deliver his topic. Mr. David Liu is a director in Malaysia National Applied Research and Development Center, MIMOS. He will be talking about interesting subject, which is data protection and cybersecurity. We welcome you to the stage.
Okay, back from the break. So let's continue. So you can call me David. I will talk about tekan sini. Mana? Okay. Oh, there. Okay, can. So today I'm going to talk about data protection and cybersecurity, right? So let's take a look. Okay. So I will focus on data protection in the context of healthcare, right? So first, let's see what is data protection. Actually, data protection is a set of process, right, to protect sensitive patient informations, okay, from unauthorized access, use, disclose, disruption, modification, or destructions. So the information here are referring to like the patient medical records, the test result, insurance claims, and other personal health informations. So next, let's see what is personal data, right? So according to the global definition, personal data means any information relating to identified or identifiable persons. So identified persons, right, is someone who can be identified particular by reference to certain ID. For example, like we have the national ID, my card, my kid, police ID, Tantra ID. So that's the ID. And also by any other factors, right? For example, their name, right? Their date of birth, then their biometric data, fingerprints, right? Or those are referring to the social identity lah. Okay. So in the context of data protections, actually there are multiple approaches, right, can be implemented. But the most fundamental one is physical security, right? So physical security is whereby you secure the area by means of maybe digital security door, or you can set up the CCTV cameras, surveillance cameras, right, to protect all this sensitive information that located in different premises. Right. Next is cybersecurity. Cybersecurity, some measure that you can take is, for example, like given a strong password, right? Implementing firewall, then you encrypt your data. So that are all relating to cybersecurity. And the third one is data governance, right? Data governance is whereby you establish a list of policy, a procedure, right, to manage your data. I find it data governance is quite crucial actually in defining whether a project is successful or the continuity of the projects. I will explain further later. So let's take a look data protection in the context of a real life example. In this case is Malaysia Health Data Warehouse, MyHCW, right? So here we have all the data source, right? You have the e-reporting, the family health, the SRP, the PRIS, the ARP, everything. This one is, we call it the transactional system, right? So your raw data all being collected over here. Then you will have the data warehouse, whereby this is all the analytics system. So the analytics system, you will comprises of data pseudonymizations, where you pseudonymize the data so that it can become you can use the data for statistical purposes, right? For analysis or for researchers that have no information, no granular information about the patient information anymore. So this is the part that doing all the data transformations, right? Once you pseudonymize, you have the de-identify, then you go to the data lake. The data lake can contain the structured and unstructured data, right? So for the structured data, it will go to the extractions process, whereby it will create the respective data mart to address all your questions, right? Your question that you want to answer. And the unstructured data, it will go to the harmonization process. This one is based on the normicity, harmonization. We will do codified, so you have more drill down analysis of the data. Then all this data that we created and stored in the data mart, then everything can be visualized in any of the kind of tools or the one that we have in data warehouse. So you can see all these applications, the transaction, the data source system, the analytics system, all run within a layer of the common layer, we call it the security and the infrastructure layers. You have all the physical machines right here. You have multiple nodes, right, of physical machine and also the database. And those applications like e-reporting, SRP, pre-safety, they are all running in a virtual machines or a container. So this one represents a container, this one represents a virtual machines. And these two are running at the physical machine itself, right? So everything is governed by the security framework, right? So we have the RAKSA security framework, the public sector cybersecurity framework. We have the DKICT. We have also comply to the PDPA Act. So this is the user from hospital, user from clinics, right? Depend on the respective role-based access permissions. Then they will given the access to each of the application here. So here, once user access to the system, first thing they need to create a patient. So create a patient, of course, you enter the patient identity. The identity can come in the form of my card, my kit, Tantra ID, UNHCR, passport, all these things, right? So for those that belong to our national identity, we can validate that against the JPN. My identity service. This one is a direct API call. So once you enter the IC, all the particular will be populated at the system itself. So you don't need to key in your address. You don't need to key in the date of birth. Everything will be populated here. So then after that, subsequently you enter create the visit record, whether it's a visit or whether it's an encounter, right? So then the encounter with the visit, then you attach all your inpatient informations, right? Or your daycare information. Inside the daycare, you have the diagnosis, you have the procedure, you have the discharge informations, right? Ward admissions, right? So all these things will key in. So once on discharge, then this information will flow into the analytics system. Likewise, it applies same to the HIS system as well. The HIS or the CIS system. This is like example like TPCOGs. This one is something like the SVP, CERNOS, ProfDoc, right? So all these things will send the information in a non-intrusive manner, right? So through the secure file transfer protocol, then information will be picked up by the relevant services within the system here, right? At the same time, some information also will pass back to external system. So here we are like case mix, right? They need to understand the cost and the type of drug that being consumed. So this information populated back to case mix. And let's say, for example, in the case of a birth label like the PD 102, right, or the death, the PD 105, all this information will be sent back to JPN because they want to update their status. So as you can see here, right, all you can see all this icon. Actually, these are all the security measures, right? These are all the security measures that is in place, right, within the entire data warehouse. So I will go into more details. So let's talk about the data warehouse security framework. So you have this one is I take for the real case, right? Data warehouse. So but the first one is we have multi-factor authentications. Sorry, so the first one is multi-factor authentications. The second one is the public key infrastructure. The third is the data summarizations. The fourth is the disputed microservice architecture. The fifth is the private cloud infrastructure. The sixth is security posture assessments. And finally, we have the data information governance. So these are all the key factors that contribute to the entire data warehouse security framework. So I will go one by one, starting with multi-factor authentications. So what is multi-factor authentications? Actually, multi-factor authentication is a process of granting the user access to the system, right? Or a website by presenting two or more pieces of evidence. The evidence here, we are referring to the factors, right? To the authentication mechanism. So it's actually the factors, if it can be categorized into something that you know, right? Like you have a password, you know your password, you know your PIN, right? Something that you know. The second one is something that you have. You might have a security token, right? Or a mobile phone. So at the security token, you can generate the one-time token. Your mobile phone, you can install the TCK, like just now the previous presenter has presented. Or you have the 2D barcode, right? You can use the one-time token or the 2D barcode within your mobile phone. The third one is something you are. So it's referring to the biometrics identifier, such as your fingerprint, your facial scan, right? So those okay. Those you can see, right? The current HTW, you have the password, right? Something that you have, right? So certificate, then something that you own, like the 2D TCK, then you have the digital ID. Of course, we haven't implement like the biometric. Biometric is something that at the front counter, right? You need the devices, or you can implement like facial recognition, all these things. So it means here you need to use minimum 2 combination of these two, or any combination between the password with the TCK or the TCK and the 2D barcode. So in any combination of the two, in order to access systems. So what benefit you will get, right? You get the extra additional layer of security, right? In order to access the application itself. So it making much more difficult for unauthorized user to gain access, right? So it can help to protect your account, right? Take over. Actually, this one usually happen if in the event of cyber attack, right? And you can protect your personal and financial information from being stolen, or your medical information from being stolen. So next, let's take a look at what is public key infrastructure. We use this a lot in HTWL system. So actually PKI stands for PKI is a set of role policies, right? You can call it a hardware or software or procedure Like in order for you to create your digital cert and to manage your public key encryptions. So the component of PKI, usually they consist of the certificate authority, the one that issue the digital cert, and the one that validate the digital cert. This is the RA, the registration authority. And the digital cert itself, the electronic documents that bind the key to the identity, right? Then you have the key pair, you have the public and private key, and also the key management systems. So I will show you how this one being used. Right. So the purpose for PKI actually is to secure your transactions, electronic transactions between your client to the server, right? So this one is, and also to protect or secure sensitive documents that you have in your system. So from the PKI, this is something that we can create the SSL cert, right? Usually is to secure the website. For example, like the Maybank to you, right? You can see the SSL cert, which is a valid cert. So you can know that actually Maybank to you site is a legitimate site for you to make your financial transactions. You also have the digital signature to verify the authenticity of the documents and messages. For remote access, you can use the public and private key, right? For, of course, the IoT devices to ensure that they are connecting to the authorized servers and devices. So here you can see here, right? So this is, we are using the remote access, right? This one is the remote access from the HIS to the file server, from the CIS to the file server. So this one, they are using the public and private key, right? So for PKI, actually, you can generate the certified public key or a self-signed public key, right? Because not everything that you need to go for the certified public key, and those you are public approach, right? You are exposed to the public, then you might need go for the certified digital cert. But those, let's say, it's the machine-to-machine communications, right? You can use a self-signed cert, right? So this self-signed cert actually is generated by the HIS system or the CIS system itself. So once they generate the cert, they generate the key pair. So we have the public and private key. So the private key, they don't share with anyone, okay? They will keep the private key. So only the user that create the private key will know that, right? And they will send us the public key. So we will put in the public key inside the FTP server. So once they log in using their key, I know that this is the legitimate user that connect to my FTP server. So, and the entire communication is secure, right? So this is how we do the communications between HIS system or CIS system to the HW. Next, I'm going to talk about data synchronizations. Actually, data synchronization is the data management and de-identification procedure, right? Which the personal identifiers informations, the PII, field within a data record are replaced by one or more pseudonyms. So this process actually prevent the data from specifically pinpoint to the user. So you wouldn't know actually that record belong to which user eventually. So sometimes the only way to pseudonymize data can be linked to the unique individual is by combining. This one is the re-identifications process. So you need to combine with another set of data in order to identify actually that record belong to who, right? So the basic concept here is that you have the basic concept is that you have the de-identifications is a forward process. Then re-identification is the you try to re-identify back that actually that data belong to who, right? So let's okay, this is how the thing works. This part is the data source. Actually, this one is quite similar, I think, previously presented, but I will elaborate further. So this one is the data source, right? Data source, you have all the name, IC, address, date of birth, postcode, city, diagnosis, right? And define these variables, the name IC, address 1, right, address 2 is your PII data, right? So what the system does is that, so through the privacy assurance service, right, it create a VPI. VPI here stands for virtual person index, right? With a random ID or random characters, right? Anything that you can define that. So A here actually is referring to the person XXX, right? But now you only can refer to the this AA, but you don't know that this AAA actually what is his IC number and where he stay, or all these things you will know. At the same time, we also create a separate set of data. This one is called the personal data with a identifiable index differently, right? CCC, right? With their name, IC number, address, and address 2, right? The same information here, but we have the identifiable index, right, to represent this one. So even though you have this data, these two data together, right, you will know actually AAA belong to CCC or AA belong to DDD. You will know that, right? So this information is stored in a protected and locked and secure place. We call it the personal data store. So, and the de-identified data that produced will be stored or will be used in your data mart, right? This is where all the statistical, you perform your statistical analysis, your research analysis, right? You can use this data to perform. So you can know the date of birth, the postcode, but you don't know actually who this person is. You only know this one is the index only, the person index only, right? So next is, let's say you want to do the re-identifications. So re-identification, let's say I select this person AAA, right, as a person of interest. I want to know in some maybe occurrence, you want to find out actually who this record belong to. So you take this person AAA, you put back in the privacy assurance service together with the digital cert, right? So we can pinpoint that this AAA is belong to CCC, right? So this digital cert added another level of security. So the person that keep this cert can be kept in a very secure place if you want to do the re-identification process. So far, okay? So now next is distributed microservice architecture. Okay. This one is more towards system architecture design of the application, how we develop the applications. Actually, we develop the applications based on this microservice architecture, right? So what it means is that instead of building develop a single applications, right? This application is broken down into collection of small independent deployable services, right? Something like this, right? Here. So you can see that we have the outgoing integration service, incoming integration service, scheduler service, demographic, patient demographic, facility demographic, right? The SNRP, oral health, family health, the ETL service, the PAS service, the master management data service, the unified application service. Each one have their own business functions, right? So they have their own rules, right? And you can deploy this, right, in multiple instances. Let's say now you have the user, heavy user, or there's a lot of user over a period of years. So you can scale this service independently without impacting the rest of the service, right? And the other thing also, let's say you want to develop this system, right? You can develop the system concurrently, independently. You don't need to wait for this service to complete. They only do the develop this service, right? All these things can be worked independently and can be deployed independently also. So in the event that this service having problem or some CR need to be implemented, you can only fix this and deploy it again, right? Without impacting the rest of the service. So this is the advantage of using microservice architecture compared to the monolithic, which is a single big applications. So these are all the advantages of flexibility, right? You can develop, deploy independently. Then you can scale horizontally, right, within your data center. Then if one service fails, it doesn't impact the entire applications, right? And security, you can deploy different services at different servers, different region of the data center as well. So next is private cloud infrastructure. So this one is a dedicated cloud computing environments, right? Dedicated for a single organizations. The advantages is that the organization have full control over the piece of hardware, the software, and all the networking infrastructure, right? So some of the advantage is that if you are dealing with sensitive data, you fully manage this data, right? And also the deployment flexibility. Let's say you deploy a new services, right? You don't need to know additional cost incur as compared to, of course, public cloud. So like this here, right? This is all the physical node, all the physical server that we are having. And this is all the containers or the VMs, virtual machines that we have. Let's say this one got is 13, 12, 10, 12, right? This one running on each of the physical node. This is all the virtual CPU that you consume, and also the memory. For example, like one of these hard disk fail, I can just move that virtual machines to another available nodes easily, without disrupting the entire operation process, right? Or the entire applications. So there, in addition, you can also use a web application firewall. Actually, this one is quite important because it further protect your applications by filtering or monitor your HTTP traffic, right? Actually, this one can prevent protect your application, especially from cross-site scripting. This one is someone inject malicious code into your web page, into your application. So actually, this one can detect that. And also SQL injection whereby you inject some script, right, in your web application that it send to the database level, right? Once you send to the database level, you can extract or you can destroy the data, right, in your system. File inclusions, this one is to trick the web applications into loading malicious file from the internet. Like sometimes your application asks you to load or to open some file, right? So this one can be controlled. And also the DDoS, this one is to make your service unavailable, right? By flooding your network. So from here, we can use firewall to web application firewall to protect the system, the entire system. So next is the security posture assessments. So this SPA is a comprehensive evaluations of organization security control and procedures, right? So it is designed to identify vulnerabilities or weakness in your organizations, and also come out with proper improvement recommendations, how to overcome it. So the life cycle of SPA, we have 5, from asset identification, vulnerability assessments, control assessment, risk assessment, recommendations, right? So the first one is to identify what are all the hardware or the software or the applications that is running in your system. We need to understand that. We want to understand how your network is connected, what is the IP address or the port that is opening. So this is all under the asset identifications. Next is to perform vulnerability assessment through pen test, penetration test. So based on the pen test result, right, then you can effectively define the security control, right? Retrieving the policy, the procedure, and also the technology. And also you can assess the risk of the organizations, like the likelihood, let's say if in the event of a security breach, what is the alternate, what is the fallback, right? Do you have a DRC site? Then how you manage the DRC site, all these things. Then finally, then you will recommend a set of improvements, right? How you can securely manage your vulnerabilities, right? And how to overcome the weakness, right? So whether it's a new recommendation or upgrade, so everything will be presented at the final SPA report. For HW, actually we done this I think every year, if I'm not mistaken, right? So we will do the assessment yearly. So finally is the data and information governance. Actually, data information is a set of processes or structure, right, used to ensure data information are managed effectively, right? And these are the aspects of data information governance. The first one is data governance. Actually, data governance is to manage the data, to define the data, right? So you need to know whether your data classification, is it rahasia, sulit, or this thing, rahasia besar, right? And the data ownership and to manage the data quality as well. So they all belong to the data governance. The next one is the information governance, right? This one manage the effectiveness throughout the life cycle, the data life cycle, right? The information security, the privacy, right? The access management, the life cycle of the data. The third one is the data and information security, right? This one is to manage the authorizations access of the data to the respective users, right? Then the final one is the data information privacy that deal with the personal data, whether in the event of data breach, how you notify or how you manage this data. So data, I mentioned in the earlier slide, data governance, actually data information governance is one of the key thing I see in a lot of projects, right? If you have this in place, actually the success rate of the project will increase further, right? That's why the benefit of implemented data governance, right? They increase the data protection, they define the ownership of the data, right? Then they also improve the quality of the data in a way. And it also enhance the decision making. You have a group of team that define who can make use of this data. And also eventually your system or your data are all compliant to the standard regulations. Okay, with that, that's the end of my presentations. Any questions?